My friends, thanks for joining. So today is the last lesson of chapter 1. We made it. So with chapter 1, we browse all layers of infrastructure, and my target is later on to give you in chapter 2 a zoom in of a security control, having an understanding of how integrate all layers and what will be the future picture in terms of infrastructure security. As you see, the chapter one focus was on explaining critical piece of infrastructure, and obviously the last two lessons are about the common problem. Today, I will discuss the common implementation issues, and I want to remind you that there is a playlist into the channel. You are free to pick the lesson that you are more interested. There is no order, and I hope you appreciate the food for thought. But let's kick off. Problem from an implementation perspective. What I mean by implementation. You design, you did the architecture, and later on you implement. Sometimes the solutioning architecture is having a lot of influence from a cloud service provider or from a product perspective. A good architecture and design should be independent from a solution, but solutioning is strictly bound to that. So one of the issue from a thinking perspective is a lot of attention on north-south path from an exfiltration point of view, but not much on east-west in terms across cloud service providers. So can happen that you have a lot of micro-segmentation conversation within an infrastructure as a service, within a pass in terms of a full mesh, service mesh, but not much about the pattern that you can find across cloud service provider. So that is one of the first implementation issue in terms of controls. You need to think also on the visibility of that traffic and how you spot it. Second problem is the GraphQL that get introduced all around all projects. GraphQL is a query language. So to perform an action, you use the REST API, and each was a call. The verbosity is going to disappear with GraphQL because it's a query language, and so your API request is containing a query. As any query language, enlarge the attack surface, and it does change the structure. One of the biggest problems that I see, not much of a thinking on these differences. You talk with automation engineer, and they don't distinguish the two. But from a security standing point, is a big difference. Another common issue that I see is a lot of security testing, not focusing on management VLAN. And also from a cloud perspective, this topic is not seen too much. And so how people manage things. Common is also a lot of attention from the front-facing interface, expecting the attack to always be from the one interface. But the truth wants that you get exfiltrated and you have a Cobalt Strike payload through a reverse connectivity. And so one of the most common issue is that engineers don't think about the reverse shell, reverse connectivity in any case. That is really trivial. DNS security and DHCP security, as I already stressed out all lesson, are extremely underrated. You need to look into that because most of the solutioning just demand those services without thinking from a security standing point. Database, the common is that we design stuff and we don't think about the visibility on that. So have a data pump command into a database and not having alarm about it is not smart. Is for sure not your case, but I'm talking generally speaking. When you are doing engineering, you should think about also the visibility in terms of incident response. I see a lot of project in engineering space that don't think about visibility, accountability, what you can really see in terms of logs. Another big issue is the CDN is doing application routing. Changes are impacting the way. Even small changes on rules for HTTP header, they should be monitored, they should be seen, they should be, and it's up. Other problem is the thinking behind SSL. You see solution architecture talking about SSL, not discriminating which kind of SSL. Is TLS 1.3? It's completely different. One can have an ASN encrypted, the other one doesn't. And so changing completely the visibility, changing the way I use. Check it out, the last vulnerability on wildcard certificates. How much that conversation is never discussed about CDN VIP. CDN VIP are the best consumers of wildcard certificate. Other is the attention to um, orchestrator, generally speaking. So an attack to an orchestrator layer can give a great result. The problem is most of these services are using external orchestration. And so you can find an orchestrator that is actually resident outside your incident response and visibility in terms of logs. That's security architecture wise should be a concern. You need to see that in that terms. We talk a lot about segmentation, micro-segmentation, but we don't talk about that from a data perspective. We talk about connectivity. But you should have also rules in terms of which data can go where. And moving that conversation at the data, suppose that you are getting more mature on the data categorization, you should know what an asset is having, which data is managing, which data is visible and handled by that system. And that suppose a mature way of doing data categorization and tracking of which data is available on which system. And so joining the asset inventory with the data inventory. Data lineage, if you want to use a common term, but for sure you need to cover the entire data life cycle because you can't focus only on just when the document is created, when it's consumed and used. You need also to see all archive, destroy, efface. So you need to have a really well-structured conversation in there. And commonly in solution architecture is not there. Another problem is the review of the solution architecture. You do have a new way of designing things because new products are available. You can't design something today in cloud and suppose that will be forever. One example is AWS was having all API public facing from an IP perspective. So you had a lot of conversation private to public. Now is only private to private, at least is optional, but you need to have a review process. And so what I see common in all solutioning is design something and suppose that it will be forever. Cloud shouldn't be subject to that. is continuously changing. A new version of API is out every 3 seconds. And so you know how agile the delivery of those API are. But if you see the documentation, also the versioning of API, keep track of that without a change log isn't easy. And so you should have more thinking in review of the architecture. All decisions that you made today need to be discussed again later. Uh, Another problem that I see is all on the endpoint, the amount of agents. The loopback traffic is the best interface forever, but that is a critical kind of situation that you should address. I mean, integrate, simplify, keep it simple, have visibility of everything, not get only telemetry through a product. Because if a product get a workaround or disable, you are going to end up without telemetry at all. And another common mistake that I see is not uh, using test. So from an infrastructure perspective, application perspective, there is a lot of testing ongoing. It should be used also for security. And that is a common mistake. You should understand that back in the days with a web application firewall, they were trying to merge the two. Nowadays, it's not anymore like that. So you should work on it. And another common architecture kind of problem in terms of solution is that everybody does have a multi-cloud without even knowing and without a strategy of multi-cloud. And so they can have stuff scattered a bit on one cloud provider, on the other cloud provider, but all these projects are generally based on something specific like the pass, the FAS, or and you don't find the big documentation with all full picture. So you need to keep updated the documentation in a dynamic manner and be 100% sure that you keep track also of the changes. It's really easy at API to do that, but you need to implement it, and is one of the problem. You find the conversation but not documentation. I know the approach of agile into documentation, but it's not right when it's touching infrastructure. Another problem is way common is the key management that is seen as a standalone topic with a lot of exception. You need to have one strategy well structured again around the vault and use API for that. Don't just have a big project on key management for later discovering that anyway nobody use it. Or at least not have in every aspect. Another issue is the gateway design for the API gateway, but I already discussed from an architecture perspective last lesson, so have a look to that. And for sure, the browser, the connectivity and the browser exploitation. If you see how a JavaScript in Magic Art how much can achieve 3 lines of JavaScript. It's just ridiculous if you think about the investment in security, and that highlights a gap. That is a thinking gap. Is not nothing else. You can design something without thinking about the layer 7 attack into a component, and doesn't change actually if it's a server, because you find so many servers not hardened enough or not having still desktop component. You should have an approach that's similar to Alpine Linux, everything stripped down, In Windows, finally, it's not mandatory to have a UI, and so you need to work heavily on hardening. That is a common mistake. Having a solution design that doesn't include the hardening process verification, that is too common. I hope I gave you a good overview. It's I think I gave you enough food for thought on this chapter. I'm looking forward on the next chapter to focus more on the specific controls. And stay tuned, subscribe so you know when I'm publishing the next lesson. Have a good one and thanks a lot for having me. Take care.